a vertical ellipse, the equation looks like this. X minus h squared over b squared plus y minus k squared over a squared equals 1. Horizontal looks very similar. The only difference is you'll notice the a squared and the b squared are flipped. Well, in an actual problem, those two denominators are numbers. So then the question becomes, well, how do you know which one is a squared and which one is b squared? In an ellipse, the a squared is always the larger denominator, and that's not on your formula sheet. You have to remember that for ellipses. So the larger denominator, if it's under the x, it's a horizontal ellipse. If the larger denominator is under the y, like you see there on the left, it's a vertical ellipse. All right. So the only thing up there that's not on your formula sheet is the a squared is greater than b squared. You have to remember that for ellipses. It's only for ellipses. Now I'm going to go through a picture of an ellipse and diagram all the pieces for you. We have a center. And like I showed you before, we have the focal points, focus points. Plural for focus points is foci or foci, depending on which area of the world you come from or whatever. It's pronounced two different ways. The distance from end to end, the long way, is called the major axis. And that is the formula 2 times a. So it's kind of a diameter, long way, major axis. The short diameter is called the minor axis, and that is 2b. And since a squared is always bigger than b squared, 2a is always going to be bigger than 2b. From those two formulas right there, you can extrapolate that the radius, long radius and short radius that I talked about, are a and b. So you can get those just by looking at the ellipse equation. You can get what the long and short radius are going to be, but simply by taking the square roots of the denominators. And we'll graph an example here. Okay. So now I'm going to show you how to graph one. I'll go through this one with you step by step. First thing I do is I look at it and I try to determine if it's horizontal or vertical. I can look at this equation and I say, oh, that's horizontal, because the larger denominator is under the x. That makes the x the dominant axis, and since x is the horizontal axis, that's the way it's going to go. So it's going to be a horizontal ellipse. Okay? So I know what my picture is going to look like. I can look at this and I can tell you it's horizontal. And then I want to find HKAB. Because from finding HKAB, I can find the center, and I can find either the major and minor axis if you want to do it that way, or I can just go up and out the A and B measures. Looking at the equation, same way we did with a circle, the H is -2, the K is +3, A squared is the larger denominator, so A is 6, square root of the larger denominator. B squared is the smaller denominator, so B is 3. From there, I'm going to graph it. So I need a center, and I need distances to go away from the center. So my center is HK. My major axis is 2A, which is 12. And my minor axis is 2B, which is 6. That's all I need to know to graph it, because that tells me how far to go horizontally and how far to go vertically from my center, negative 2, 3. Okay, so I go to my center. I know it's horizontal. Again, because the larger denominator is under the x, that's what makes it horizontal. So my major axis is horizontal. It's a distance of 12 total. So each way from the center, I'm going to go 6. That way I have a segment that is 12 units long from end to end. Horizontal, because it's a horizontal ellipse. Major axis. Or you could just think A is 6, so I'm going to go 6 each way from the center. Minor axis is 6. So my minor axis top to bottom has to be 6, so I'm going to go 3 each way from the center. And then you draw your ellipse. Looks something like that.